Everyone, welcome to workshop number 5 of our beginner track, which is the FPS shooter part 1. I'm Ryan and I'm here with Aaron to lead this tutorial. Before you start, you want to make sure to download our skeleton package, which can be found on the link over here. Additionally, you can follow along with the step-by-step guide on our GitHub repository on the link right here as well, and a link to our slides is also listed here. So let's go over a brief overview of what we're going to go over in this tutorial. So we're going to mainly focus on implementing 3D movement, as well as adding FPS camera mechanics with Cinemachine. So you can go ahead and follow along on the README. You're gonna want to open Unity on a new project and install the package and import it into the Unity into your Unity project. And if you have any questions, go ahead and message in the Discord in the questions channel, and an officer will go ahead and help you out if you need any assistance. So this is just saying what I mentioned before about installing skeleton package, but additionally you want to install the input system, Cinemachine, and universal RP packages into your Unity project. I'll go ahead and show how you do these steps in Unity itself. Additionally, this next step about creating a new pipeline asset you'll have to do in order to render everything with the universal RP package. So for player movement, we're providing a lot of the skeleton code for you, so it's not so you don't have to learn a lot of the nitty-gritty of it, and you can really focus on learning the fundamentals and the essentials when it comes to coding Unity, because we found that it was a little difficult to follow along when you had to write code from scratch, and then it might be more helpful to follow along with more of a general backbone to it. So we're gonna link our input system to the code using the new Unity input system package. Additionally, we're gonna want to calculate velocity and move the player based on these inputs that the user is putting in, and implement some basic jump mechanics. All right. So if we hop into our Unity scene, after we've imported the package, you're gonna want to also install the other Unity package or the other Unity packages, which will be Cinemachine right here. If you go to Window, Package Manager, and Packages Unity Registry, you can find these packages. So Cinemachine right here, you're gonna want to install that. Additionally, you're gonna want to install input system as well as universal RP. So when you first open the scene, in the scenes folder right here, you're gonna see everything's this kind of magenta color, which is not really how things are supposed to turn out. And that's because we haven't really added a pipeline asset, or we haven't really linked the universal RP package to our prefabs that we have currently loaded in. So things currently don't look the way they're supposed to. So what you're going to want to do is right click in your project area and go to create, head over to rendering, universal render pipeline, and pipeline asset. So this will create a universal render pipeline asset, which you can then go ahead to edit project settings, and under graphics, you'll see that there's no scriptal render pipeline asset here. So in order to load things in properly, you're gonna want to drag this new universal pipeline asset you just created into this empty slot right here. And then everything will be loaded in properly. So in this part of the tutorial, I'm going to be mainly focusing on 3D movement. So you're going to want to head over to your scripts folder and open the character movement tutorial.cs script. Okay, so once you open the script, you'll see a lot of to-dos here. So I'll be going over each one to make sure that we get everything up and running, and I'll try to explain everything to the best of my ability. So over here, we're gonna want to set a serialized field of a head camera. So we're gonna want to get a reference to the actual player's head. The reason why we're doing this, and the reason why this is like a camera, is because we want to get the direction in which the camera is facing, so that we could move the player in that direction. So here's some just generalized values, max speed and jump height, so we can later on edit them to make sure so we can edit how high the player jumps and how fast the player can move. So right now we're initializing a desired direction and current velocity vectors, and we'll see these later on. These are basically going to be the desired direction is going to be the direction that we want the player to move in, and the current velocity is self-explanatory. Um, Vertical speed is the speed in which we want the player to be jumping in. And here are references to our movement action input, our jump action input, as well as the animator. So let's go ahead and get started with some of the to-dos over here. So we want to get references to input actions that we care about, which are movement and jump. So what this basically means is that when you're dealing with a new Unity input system, if we go ahead and head over to the Unity and head over to the robot player, we can see a little um, player input game object attached to it. So this includes player controls, and these are basically some of the defaults that come when you create a new player input and create the default controls. So we have movement right here, as well as jump and rotation, and we'll be using rotation later on. But movement and jump. So basically, these input actions will take actions from your keyboard. So you can see right here, space from your keyboard and WASD, and we can manipulate what these values do by getting references to their actions. So, so now that we know that we've seen the player controls over here, we can head back over to our script and get actual references to them. So over here, we want to say movement action equals get component. This is a little bit of a long line. So basically what this means is that we're finding the player or the mapping for the player, and we're finding the movement actions which are associated with it. So if you want to head back over here, you can see that our movement actions are right here, which are WASD. So heading back over to the script, we can basically do the same thing for our jump action. So I'll go ahead and just copy and paste this over here, but instead of movement, we want jump. So this will get our jump action. And for Animator, we basically did a lot of or imported a lot of animation stuff for you guys already. So we just need to get that component over here. So get component. Okay. Now we can go ahead and move on to the next part of the tutorial, which is hiding and locking your mouse so you don't get distracted. So in general, when you're playing an FPS shooter on your computer, you don't want to see your mouse or you don't want to see your cursor because it would get really distracting and you can't really focus on shooting. Additionally, you want to lock it so that it's always in the center of your screen. So when you're like looking around to shoot other players or objects, you don't want to be like dragging your cursor to the edges of your screen. So to do this, first to hide it, we can set cursor visible. And next up, we can set cursor. This will lock our cursor in place, and this will set our cursor to invisible. Next up, we can head over to our update function. So our update function is going to be called once every frame, and we're going to want to be moving our player as much as possible based on the inputs. So first off, we want to calculate the forward direction vector that we want the player to move in based on the direction that their head is facing. So our desired forward vector, we're going to want to create a new vector 3, and the floats that we want to make them are, so first off, we're going to want to move them in the proper X direction. So we can do head camera X. So this will move our player in the proper X direction. Now the Y direction is a little different because our Y direction is going to be not, our player is actually going to be moving on the XZ plane. The Y direction is going to be like the way in which the player is like looking up and down on the screen to like shoot things. So we're not really focused on that on our movement. I apologize if that wasn't completely clear, but this is like this whole plane that the player is going to be walking on is the XY plane, and that's the only directions in which the player can move in, basically, except when they're like jumping. But for our basic like 3D movement, we're going to want to be focusing on the X and Z components. So we can set that to 0, as well as our last component, we can set the head camera.transform forward z. Okay, now we have the desired forward vector here. Here we're actually transforming the player based on the desired forward vector. So that's just what we're doing over here. Next up, we're going to want to calculate some velocity values. So here our hint is to use mathf.smoothDamp. So basically we're going to we're using mathf.smoothDamp so that we can move our player in kind of a smooth way, so it's not like very sudden, like jarring movements like back and forth. We want the movements to be actually pretty smooth. So we can go ahead and do current velocity.x equals mathf.smooth, and then we want to dampen our velocity x, so that's our x velocity, and we want to go to our desired direction, x times our speed. So direction times speed is going to give us the velocity vector in that direction. Next up, we're going to want to put in our third component, which is reference curve x, and then smooth. So mathf.smoothDamp is a little weird. So it's like what it's doing is it's taking in the velocity that you're at, which is like current velocity.x, and then it takes in the velocity that you want. So it's desired direction.x times max speed. And then it takes in some variable you want to store that in. That's why we have ref.curvel.x over here. So we're just storing this data into this reference that we're creating here. And we also want to add a factor to smooth things out. So a factor of how we want to like ease the movement between the current velocity and the desired velocity. So we're getting the current, again, one more time, we're getting a current velocity, our desired velocity, storing it into some variable, and we're seeing how smooth we want that to be. So we can go ahead and do the same thing basically for our current velocity.y. So if we just change these, copy and paste, change these to y, that'll work all right. So next up, we can go ahead and move on to this right here, determining how to change the vertical speed of the player based on the character's current state. So we want to determine how we want to move the player when they're not grounded, and if they're based on like these states. So if they're falling, if they're landing, and if they're standing. So if they're falling, we want to apply gravity. So we want to do vertical speed minus equals gravity times time. So this is basically going to, so multiplying gravity by time is just going to grant us the velocity or speed that we want, and subtracting it will make it so that we can get, we can apply the gravity based on the time that's passed. Next up, we're going to want to set our vertical speed if the player is landing. So we're gonna, if the player's landing, the speed's gonna be 0 because they're gonna be like on the ground. And lastly, if they're standing, we don't really want to do anything to change the vertical speed because they're not really like jumping or anything. So next up, we can move on to this next part, move the player based on the calculated velocities. So to do this, we're gonna want to call transform translate then we're gonna want to create a new vector 3 to create a vector in which in the or so that we can move the player based on the current velocities. So current velocity dot x, we want to move in the y direction based on our vertical speed, and we're gonna want to move in the z direction based on our current velocity dot y. This might be a little unintuitive, but then we over here we define current velocity dot y because it was like based on like the direction in which the player was facing, we had to use y. So current velocity dot y over here, and then we're gonna want to multiply everything by um, time time, and this will multiply by time over here cancels out like the velocity or the over s components in like physics and gets our actual uh, positions that we want to translate by. And over here, this seems all pretty good. And what we're doing over here is animating the player based on the current velocities. So we're gonna move on to the next part over here. So this is basically trying to figure out how to detect when the player is actually on the ground. So what we're doing here is we're creating a ground checkbox. So we're going to be doing like a box cast onto the ground on the player's feet so that whenever this box is in contact with the ground, the whole player will stop and the box will detect that the player is actually touching the ground. So to go ahead and get started with that, we can determine whether the player is touching the ground with a call to physics.box cast. So is grounded, we want to change to physics box cast. And then we're going to want to uh, apply some values to this. So we want to get feet transform dot position. So this is first the argument of physics dot box cast is getting the position of the player's feet, or like the position of the box in which you want to cast. So we want to cast the box on the player's feet so they determine that whether the player is touching the ground. So we want to do feet transform dot position. Next up, we want to determine the size of the box. So we can do new vector 3 side length over 2 step side length over here. So these are some variables that Aaron and I created to, or mostly Aaron created to create a box that would work pretty ideally. Next up, the next arguments of this physics.box cast will take in vector 3 down. So this is our down facing vector. So it's like the face in which we want this box to point in. Next up, we have to pass in a quaternion. So we're going to pass in quaternion identity. And lastly, we're going to want to do ground cast distribution. So we know how to like really cast the box onto the ground. So basically physics.boxcast is going to return a Boolean whether or not the ground is or the player is touching the ground. So is ground will return true when the player is touching the ground, and it will return false if it's not. So this box physics.boxcast takes care of all of that for us. So we're pretty good on this front. Next up, or I can explain some of the other things right here. So this is animator.setBool is grounded, is basically just setting setting a Boolean value for our animator to make sure that our player stands correctly when they're grounded. On draw Gizmos over here is just drawing the the box casted box, or just drawing the box cast so that we can see it. And this really isn't necessary for functionality, but it's helpful to see in case you're debugging or you just want to see the box in general. So next up, we can work on our on enable function. So we want to set up listeners for events broadcasted by input actions. So the way in which we're doing this tutorial is a little different from before. We're using C# events instead of, well, I think we're using like broadcast messages before. So this time we're doing things a little bit differently. So we're going to need to set up listeners for events broadcasted by these input actions. Um, so on enable, we're going to need to call, or we're going to need to say movement action dot performed plus equal handle change move direction. So handling our changed move direction, so what this is basically doing is saying that whenever a movement action is actually performed, or whenever the input is put in for moving the character by like the user or the player, we're gonna want to listen to that and actually import that input into our script so we can mess around with it. Next up, we want to say movement action dot cancel equal to handle cancel move action. So this will, whenever the player lets go key, we want to cancel that movement or stop that movement. Next up, we want to say jump action dot performed. So this is basically doing like the same thing with the movement action. We're just handling the jump, and we're whenever the jump is performed, we want to make sure we're listening for that. So next up, for on-disabled, it's important that we unsubscribe these listeners from events broadcasted by input actions. So whenever something, so that it's more of like a safety thing, or like a good coding etiquette type of thing, because we don't want these listeners to be constantly like always listening, because that can take up some unnecessary memory. So if we unsubscribe these listeners from these events, then it'll help a lot with like performance, but also with just general good coding. So next up, so when for on disable, we want to say movement action not performed minus equals, and then cancel. We want to change all these to minus equals to stop handling that, or stop listening for those events broadcasted. So next up, we could actually start heading into some of these functions. So handle changed move direction. We want to say our desired direction equals our input context, read value, and then so basically what this is doing is that we're getting so earlier so our input context is going to be or we're putting in input action callback context input context, so we're getting our input based on what the player is inputting into their controls or the keyboard. So whenever they're doing something like that, we want to read the value that they're inputting and determine which direction the user wants to move in based on these inputs. Over here for handle cancel move direction, whenever the movement direction is canceled, or like the inputs are canceled, we want to stop moving. So desired direction is going to be back to 2.0 over here. Lastly, for handle jump, we're going to want to calculate the initial vertical velocity of the player based on how high we want to jump. So we can set our vertical speed equal to physics equation. So we can do dot square root and then 2 times gravity times jump. And lastly, we're over here, we're setting our animator to has jumped so that we can trigger the animator whenever the players jump to animate the jump. So I think that's about it. I'll go ahead and head over to the actual project and we can test things out from here. So if I press play, it seems like there's an error right here. I'll go ahead and fix it. Okay, so it's cursor lock mode. No. So next, so I'll compile the script again. Okay, so if we head over and play the game, we can see that our player is actually moving based on the inputs that I'm putting in. So moving left and right, you can see that it handles changing directions and moving in the same direction pretty well. So wherever the wherever the player currently we don't have it so that the direction which the player is facing moves along with your movements or with your mouse, so you can't really change the direction you're facing right now. Aaron's gonna be working on that right after this, but it seems that we have movement covered pretty well over here. If you have any, um, if anything was unclear, you can go ahead and head over to the GitHub repository and you'll see a lot of detailed notes on the actual script that we linked as well as on the README. So now I'll pass it over to Aaron.
Hi everyone, this is Aaron, and now we're going to move on to the second half of our first-person shooter tutorial, which is the camera. Basically, we're going to focus on how we get that classic FPS look and how to move around the camera using your mouse. All of this implemented with Cinemachine, which you've used in previous tutorials. So the first thing that we're going to do is we're going to try to put our camera into our scene. If you remember with Cinemachine, we use virtual cameras and not sort of the default camera that we start off with, like this main camera. So the way we're going to create a virtual camera is we go to our Cinemachine tab on the top and we go to create virtual camera. So you'll see CMVCam1, Cinemachine virtual camera 1. Um, and so this is going to be our head camera, so we can rename this head camera. And then what we want to do is we want to go and find out where where the head of the player is. So we're just going to actually, sorry, first thing that we have to do is we have to set the right parameters on this camera, right? We have to set it up so that it knows it's a first-person shooter camera and it has the right settings applied to it. So if you can see over on the right side, let me move my camera over here. If you can see on the right side, what we really care about is um, this setting right here next to body. We want to set it from transposer to hard lock to target. Now what this is going to do is it's going to go and make sure that the camera keeps exactly the same position and rotation as whatever we put inside this follow transform here, which we want to be the head, right? We want the camera to be literally like right on top of the head so that when we move our head up and down, our camera also moves in the same way. And so now the tricky part is finding where the player's head is. So we're going to go under robot player, right? This is our model that we're using. We're going to go under BIP001. And so this is sort of everything under BIP is like the skeletal structure of the player. So you can see if we go here, we can see that this is like the pelvis area, or this consists, it's like an entire hierarchy of all the bones in the player. And so we want to go and try to find the head, which is, and it's sort of in reverse order where you have the pelvis is the parent of the spine, which is a parent of the neck, and then up from the neck we can reach the head. Um, and what I actually found worked a little better was instead of using the head itself, we can use the head nub, which is a transform that is typically used for like hats, things that you would place on top of the character's head so that it looks right. you would put it under this transform. But I found that it works a little better for our purposes if we use the head nub instead of the head as the transform we want to kind of attach our camera to. So we're going to go to our head camera, and then under this follow section over here on the right, we're going to go and drag in head nub. We could drag in head, whichever one. And you can see our camera, which was on the right, it instantly locked to the player's head. So now if we were to go into game, right, we can see that it's going to be moving with the player's head now. It's hard locked to the player's head. So now there's one thing, and that's it. It's not quite right. Let's see. The camera is a bit off. It's like we're not we're sort of in a weird rotated position. So what we want to do is we want to reset the transform of the camera so that's looking straight forward again. And to do this, I just click the three dots on the right over here above the transform, and I go to reset, and it'll set the rotation to 000 and scale 1111. I'm not sure why the position didn't reset. Um, I believe it actually has something to do with the position being hard locked to the transform of the player's head. I believe that's why some machines overriding those values and making sure that we can't adjust that. Um, yeah, I see. Yeah, so the position is just going to be attached to the player's head, and that's why we can't modify it. Um, okay, so now that we have our camera put onto the player's head, now we can dive into the code itself. So if we go back to our slides, so this is where we just were. We added our Cinemachine to the player's head. We put in our information about it. Um, and then the next step is, sorry, I'll move my camera again. The next step is we're going to dive into the code and actually make a script that will help read in inputs from the mouse and uh, and cause the Cinemachine camera to rotate with our mouse. Okay, so let's see. So we're gonna go into um, character look controller tutorial. That's sort of the script that we want to modify. And if you downloaded the package, you'll have this script available. This is all skeleton code stuff, so you should have this all set up. I also just want to make a quick disclaimer that a large part of this code right here is derived from a tutorial online. Let me see if I can get the link real quick from right here. Uh, this YouTuber made Sam Yam. She made a tutorial on this that can also cover this in more detail if you want to check that out. But this link to the tutorial can also be found in the solution code, which is character look controller right here. Just wanted to put that out there. But so hopefully we'll try to walk you in. Uh, we'll try to walk you through the code so that's easier to understand when you do go into that tutorial if you want to check it out. Okay, so the first thing that we want to take a look at here is we want to set up our reference to. Okay, oh, sorry. Before I go too far into this, what we're doing is we're making a script that we're attaching to the Cinemachine camera. So basically over on this side, right, we have our head camera selected, just like a regular game object. We just want to add a component here, and we're planning on adding our character look controller tutorial, adding it to the Cinemachine camera so that we can modify its values and stuff like that. So just a thing we're putting on the Cinemachine camera just to help change the camera based on our mouse inputs. That's what we're kind of aiming for here. Okay, so the first thing we want to do, as always, in our wake function, we want to do a lot of, we want to cache our values, store references, uh, um, so that we have access to it later. Once again, the reason we do this is so that we don't have to kind of call these relatively costly functions of getting references to things in the scene in an update loop. We would rather do it first one time at the very beginning so that we can just keep going back and accessing our cached value um, instead of having to run the function to go and find it in the scene every single time. Okay, so the main reference that we would like to get is this rotation action reference. So this is of type um, input action. And if you remember from the input system, the new input system, and input action is essentially, I think it would help if I brought it up here actually. So let me just open up this. Okay, so you can see in this little window, these are input actions over here. In the last section, we went over movement. We looked at how to get input from this movement action, and the jump action too. But now we're going to look at the rotation action here. Um, and so this is just sort of a breakdown of the different possible things that the player can send as inputs. So in this case, we want to take a look at inputs related to rotation, which we've specified as being changes in the mouse position. So you can see that a rotation action is caused by a change in the mouse position or the delta mouse. So that's what we're looking at here. We're basically getting a reference to, we would like to store a reference to these actions of the action map that we're using for our current input system. We'd like a reference to this little part here, the rotation part, and so that later on we can use that and get information about the mouse change from that little section of our input map. So the way we're going to do that is we're going to, so player input dot actions. Okay, so player input, this is just a reference that we're going to assign in the editor itself. So like in our Unity scene for our robot player right here. Oh, sorry. I mean, in the head camera, this player input section, we're going to assign it to the robot player's input module. So that's this right here, this little input module here, which comes with the new input system. And remember, this is the way we get access to this action map here. So our head camera is going to want access to this input action here, and this input part here, and it's going to do that by getting it through the input component. So yes, okay, so we're going to go to actions, and then we're going to call the method find action map. And what this will do is we're going to go and get a reference to player here. So player, we're going to get our action to our player map. And from our map, we want to get access to our rotation action. So from there, so first our action map is called player. And then from there, we want to get our action map called, or our action called rotation. So well, typically when you see in Unity these methods that say find action, there's like find game object, find with tag or something like that. Usually that's a sign. Usually those tend to be costlier because they do scanning through uh, all the items in the scene, and they check if a certain string matches something else, and so you really don't want to be scanning through all the game objects with every frame. So this is once again why you do this in the wake. You only want to do it once, so you have access to it later. So now we have a reference to our rotation action. Once again, this part, this little section here in our action map, and that's going to give us information about our mouse changes. So the next part now is to dive into the main portion of the code. So this looks a bit funny, this super long signature here, post pipeline stage callback, and then all these complicated parameters that we pass in. But essentially what this is um, we're adding an extension to the Cinemachine camera, and Cinemachine has built an interface for us to use to implement um, so that it works with its system, right? The whole point of an interface is to design it so that any implementation that someone can think of will not mess up your system. So that's what Cinemachine is doing. Cinemachine is creating this interface for us, right? In this case, it's a super class called Cinemachine extension uh, that we're creating a subclass of that basically ensures, actually, I'm not sure if this is yeah, so it's an abstract class. So essentially it's sort of like an interface. Basically it forces us to implement certain methods that the Cinemachine system is guaranteed to be able to use and work with. And so one of those methods is called post pipeline stage callback, which is essentially a function that Cinemachine will call when Cinemachine is in the right place. After Cinemachine moves through a certain stage in its process. So the way Cinemachine works is it goes through several phases to in its positioning of the camera, its rotating of the camera. Um, it's kind of similar to how um, in Unity you have your awake method called, and then your start method, and then update calls, and then update, and then late update, stuff like that. There's like a scheduled order to things, and similar Machine has a scheduled order to things. It has um, 4 different stages. And once again, if you want to look at more detail on that, you can check out the YouTube video on this. But the main idea is that there are different stages, and at each stage, it's going to call this function here. Um, and then we can decide what it will do uh, once this happens. So this is sort of like an optional function, or not an optional function. Basically, when we implement this, it'll call our implementation during the Cinemachines looping through all the stages. And so um, basically all this information here is Cinemachine is essentially going to pass us information about like the current state of the camera, right? It passes us a reference of the camera itself, what stage it currently entered, right? Because this happens every stage, so we want to know like what stage this currently is. Um, Camera state, this has to do, I believe, with um, we're going to be using it for setting the actual position of the camera and stuff like that. Delta time is how much time has passed, I believe, between the frames. Once again, I'm not completely sure, but this is just sort of information that you would need to get an idea for where the camera is at the given time, component time. And remember, this is the specific callback. This is for the specific virtual camera that we're working on. Okay, so basically, we're going to go through here. This is just to make sure that we're working on the correct stage. Um, the idea is that um, we're trying to adjust the Cinemachine camera's parameters at the correct stage so that we get the right behavior we want. Um, it's important to note that we're doing it this way, right? We're trying to change the position or the rotation of the camera at the correct moment in time so that it doesn't interfere with what Cinemachine's doing, right? So sorry, we're going to take a step back. The whole point of this script here, of the character look controller, is to allow us to translate our mouse movement into a rotation of the Cinemachine camera. And the way that you would probably think to do this is just create some script that gets a reference to the camera and then modifies the rotation of the camera. Instead of going through this whole extension thing where we're putting our implementation inside this special uh, method that we have to implement. And the reason that other one doesn't work, like just trying to modify the rotation directly in an update loop, is because it's I based on my understanding, it's like sort of undefined behavior in that you don't quite know when your rotation is going to happen um, in relation to Cinemachine's own rotation. So Cinemachine is actively transforming the camera based on the parameters we put in, like hard lock to target, stuff like that. It's actively changing the transform in a certain order. So if you can imagine, if we end up trying to change the rotation, or end up trying to change the transform or something before Cinemachine actually does its rotation based on the parameters we put in the editor, then our original changes are going to be overwritten, and then we're not going to be doing anything. But alternatively, we could also have the possibility where we have Cinemachine doing its rotation, and then we end up changing its rotation in our update loop, in which case our change would be first. So it's kind of like we don't have a solid idea of when things are going to be changing, and we could potentially overwrite things, and it's just sort of undefined what's going to happen. But this sort of gives us a guarantee right here that we're always going to be changing the camera position at a valid time. And at this stage is when we're trying to change the rotation of the camera. And so we're sort of guaranteeing that we're going to be changing the camera at a time when our change is going to be the last one, and our change is going to be the one that's going to cause the camera to rotate, right? So Cinemachine is going to go perform its transformation, and then we're going to go perform our extra rotation or transformation based on our camera movement, or based on our mouse movement, sorry. So this is just checking that we're at the right stage, we're at the right point in time to make these changes right here. So we're not going to take a look at that. What we have to do now is we want to go and set up this part. So mouse delta. So this is the part where we're grabbing input data from our mouse changes. And so one way we can do that is we can go and access our rotation action. So remember, this is the one that we cached at the very beginning, so we don't have to keep calling this. So we have a reference to it, we have our pointer to it, and then we can call read value of vector2. And from here, what this will do is it's going to go and look inside this input action, right? So it's going to go here. Sorry, I have to load. But it's going to go and find this rotation action, right? So you can think of this as sort of like um, a box, uh, like a packet of, like sort of a storage unit, and we're reading in the value from the mouse position. Okay, so maybe it might be better if I'm going to bring up Paint. Uh, so uh, so you can think of this as like this. So this is our input action or something like that. Um, this is actually rotation action. And this is like a data structure of type input action. But so we have sort of the latest value here. This is a vector2. And remember, we can set this to whatever. This could have been an int. It could have been a bool or whatever based on whatever we set up in this window here. See, we set it to a vector2. Our delta. This is a vector2, and so we kind of set up this rotation action box as holding a vector2, and it has some other information here. But the main idea is that we're trying to read in this value right here. So it might be like negative 0.1, 0.5 or something like that. And this changes every time our mouse changes. So if we move our mouse to the right, then we're going to, let's see, so that would be an increase to our X position. And this might, I don't know, this might become like 0.7 or something like that, because we changed our mouse 0.7 our change in our mouse X was 0.7 or something like that. Um, and so this value will change based on our mouse. And so what we're essentially doing is we're just going and reading out that value here to find out what our essentially our last mouse change read in was. And this is a little different from what we did in the movement code doing input stuff, where essentially we would kind of set up a handler for when this value changed instead of directly reading from it itself. So in our other version, in the movement script, when we were reading input from WASD, the way it would work is essentially when this value changes, it would broadcast an event that we'd listen for, right? We'd have like a separate function that's listening for an event. And once that event happens, our kind of handler function would go and receive information about what that change was. So in this case, it would receive information, oh, we're 0.7, 0.5 now or something like that. And then this handler function would decide what to do with it. In this case, it would be like, oh, we're going to move our character forward now that we heard this event. Um, and so so that's called like the event listener model. And what we're doing in this case is more of like a polling kind of model, which is kind of what the old input system was about, where it's like every update loop we're checking to see what the input value is, instead of waiting for an event, waiting for a change from the input system, so that we don't have to constantly check. But because this is sort of a thing where the Cinemachine camera is running this every frame, and it needs to know what the latest value is at every time we run this, we're kind of forced into doing this polling sort of style where we're just reading in the value every time this thing is called. So yeah, so we're getting our mouse delta data, and this is essentially getting the latest information about what our latest mouse movement was. And so now the next part is we want to go ahead and figure out how much to change the rotation, right? Change our camera rotation based on what our mouse movement is. And so this can get this can be a little tricky because so the way this is set up is so this desired rotation is just going to be our you can think of it as like a vector 3 that's going to store information about how we want to rotate our camera, right? So how much we want to rotate it about the y-axis, how much we want to rotate it about the x-axis, right? And so if you think about it, when we rotate about the y-axis, we're changing our camera left and right. We're rotating left and right. I believe it's the yaw of our camera. We're kind of scanning left and right when we move our camera. So it would then make sense that we don't want to change this when we move our mouse up and down, but we want to change this when we move our mouse left and right, which corresponds to the x component of our mouse delta, right? How much we're changing along the x axis. And so the way we can do that is, so essentially we want to change our current rotation that we're at, the desired rotation that we want to transform to, we want to change it based on how much we moved our mouse across the screen. So we can get that with our mouse delta dot x, right? So once again, we're rotating about our y-axis, right? Our y-axis here, we're rotating about that, but we're moving our mouse x, we're moving across the horizontal direction in order to get that rotation to happen. So we're going to kind of come up with a sum here, some degrees that we're going to add to our rotation based on our mouse change in x. Um, and then we're going to, like we do with all our other movement stuff, we want to have it based on some velocity, so or some speed, so that we can kind of control how much we're rotating based on the mouse position. So this is just sort of like a scaling thing. If we want it to move faster, we just increase the horizontal speed. It's just a plain constant scalar thing that we can specify in the editor. This would have to do with like your sensitivity, your mouse sensitivity. And then, like all the other ones, we want to multiply it by time dot delta time. The reason for this is just to make it smoothed out and make sure the speed is consistent, independent of our frame rate that we're having. So now the next part is we want to go ahead and do the same thing, but for our x-axis. So this is looking up and down, right? Because the x-axis in Unity's system, it's a left-handed system, so it kind of looks like this, where the z-axis is pointed outwards, y is up, and then x is pointing to the right. I'm not sure if it's mirrored here, but um, the idea is that the x-axis is what we rotate around when we look up and down. And so we want to change that rotation, the rotation in the across the x-axis when we move our mouse up and down, which is our mouse delta y, right? Moving up and down on our screen space. So that's time dot delta time. Okay. Okay. So now we've effectively, now what we're doing is we're changing our rotation based on our mouse inputs, which is what we want. Now, one thing that we can do is that actually I think it might be helpful to show what this looks like now. So basically, so we've established what our rotation is going to be, right? Based on our mouse movement. That's this part that we did right here. But now what we want to do is we want to actually set the Cinemachine camera rotation to match that rotation that we did. So essentially we just decided on the value, but we didn't tell Cinemachine to change the camera to that rotation yet. So that's what we'll do here. And we can do that by just inserting our values here. So we want to put in starting rotation, desired rotation dot x, and then desired rotation dot y. And once again, this quaternion dot Euler thing is essentially just taking in our 3 rotation values, converting it from Euler angles to quaternion, which is the rotation, which is a way of specifying a rotation that Unity uses, and which is not as prone to gimbal locking, which you can read about more in other videos or in other articles. But just for now, essentially all it's going to do is it's going to convert our rotation that we made into it's going to just convert it into quaternion, which um, is going to just then be assigned to our camera. So if we save that and head back into Unity, what you'll see is that when we enter the game, we should be able to, yep, look left and right, with our mouse. Sorry, let's see. So we're not able to look up and down for some reason right now. Let's see why that's the case. Okay, so I just realized it's because I'm deviating a little from um, the actual tutorial I did in person, but it's because of this part here. We're going to go and do something with this later, but I was essentially overriding it with 0, and that's why we weren't seeing the change. So now if we go into Unity now and then start our scene, we should see that, yep, we're able to look up and down, but you can see that we can go past the neck, which is very awkward and does not look quite right. So what we want to do is we want to clamp this, right? We want to make sure that we can't look all the way up and like kind of turn around and do all this crazy stuff with our neck. And so that's the important part that we were missing, which is this part about clamping our ankle. So we want to basically clamp. And clamp means to just restrict the range of values that we can go to between a certain set of numbers. And so there's a special function in Unity's in the math library called clamp. And what we can do is we can set in our value when we clamp. So that's our desired rotation dot x, right? Or y, right? We don't really need to clamp the left and right because I mean, it's like our neck we can kind of rotate as much as we want in that direction, but up and down that needs to be clamped because we can't turn our neck all the way behind ourselves. So, excuse me. What we need to do is define our clamp values. So negative vertical clamp angle, and these are just angles that I've set at the top here. These we can change in the editor. They're just variables that we can tweak. But these are our clamp angles. I just set it to 80, right? 80 degrees up and 80 degrees down. That's kind of the range we want. We can adjust these however we want, but these are just values to start off with. And then as you can see, so once we save that and we head back into the editor, um, you'll see that now when we go into play mode, we won't be able to, yep, see, it locks to this position. So we can't go past this. We can't go up. We can't go past a certain point, and we can't go down past a certain point. So that's kind of the behavior we want. And one thing is, so if you're doing this alongside me, you'll notice that the camera's inverted. I'm moving my mouse up and it goes down, and I'm moving my mouse up, or I'm moving my mouse down, it goes up. And so the way we can fix that is we can go ahead and change our desired rotation to negative here. And essentially this just means it's going to go in the opposite direction that we would normally have put in had we moved our mouse up or mouse down. And so when we go in and move to our scene now, what we'll see is, or there's no visible difference, but in terms of feel, I'm moving the mouse up now and the character's head is going up. I'm moving it down, the character's head is moving down. So now we have um, our full camera um, movement here based on mouse inputs. And you can tweak the data on the side however you see fit. Maybe it's too fast, so you can change the sensitivity, you can change the vertical clamp so that it's not as you can't go as far, just based on preferences, stuff like that. Um, and so you can go and move around freely now in your world. Okay, so that I believe wraps up the portion on Cinemachine on our rotations, everything to do with our mouse movement. Um, and um, So I just want to end by saying that Cinemachine is a very powerful tool that saves you a lot of work implementing a lot of camera stuff to make things look a lot better. Cinemachine can be used in a lot of different situations. We didn't show it here, but um, we didn't get to it in these tutorials, but you can do some really cool stuff with scoping, where if you hold the mouse down, your virtual camera would transition to another one that's just like a scoped version, and you can get like a really cool narrowing effect. You can do Cinemachine things with third-person stuff, so like more of a Breath of the Wild sort of thing, or a third-person shooter. And there are tons of tutorials out there that Unity has made going over the different things you can do with Cinemachine. But this is just one of them using for the FPS camera, which is relatively simple. Um, and so with that, thank you guys for watching this tutorial, or if you already attended the live session, thank you for being there. And I hope this will help you guys get started on your first FPS projects. And you don't even have to do this last camera part that I talked about in Cinemachine. You could just do it with a plain old camera, but Cinemachine will be a very powerful tool that you can use in a much broader range of applications. Um, but with that, thank you guys all for watching.